Hi everyone, this is Aman Kumar. Welcomes all of you at Brilliant Academy. In today's lecture, we are going to learn our next chapter, that is circles. We already studied about chord and arc of a circle in our class 9th. Now, at that time in class 10th, we have to study about tangent of a circle. Okay, so let's start our today's lecture. Now, first we see what is a tangent of a circle. So look, tangent is what? Tangent is a line which intersects a circle at only one point. Look at definition. A tangent to a circle is a line that intersects the circle at only one point. So tangent is a line which intersects the circle at only one point. Look here, suppose this is my circle with center O and one line. Suppose this is one line AB. Now see, this line AB intersect this circle at this point, and I name this point as C. Then this line AB is a tangent to the circle with center O. Tangent to what? Is a line which intersect the circle at only one point. So look here, this line AB intersect this circle at this one point. So this line AB is a tangent to this circle. See, we take one more example. Suppose this is my line EF. Now see, this line EF intersects this circle at again this point. Then this line EF is also a tangent for this circle with center O, and we name this point as M. So tangent is what? Tangent is a line which intersects the circle at only one point or touch the circle at only one point. This is an example. This is a circle with center O. Look for line AB intersect this circle at one point, that is C. Then this line AB is a tangent. Line EF again intersect this circle at one point. Then again line EF is a tangent. If I draw a line like this, so this is my line PQ. Now look, PQ intersect this circle at 2 points. First point is here, second point is here. So PQ is not a tangent. Okay, so PQ is not a tangent. Why? Because this line PQ intersects this circle at 2 points. Tangent is a line which intersects the circle at only one point. Then we said this line is a tangent. If a line intersects the circle at 2 points, then we say this line is not a tangent. Okay, I hope you all understand what is a tangent. Now next we have to learn about some theorems which is related to the tangent of a circle. So look, this is my first theorem. Theorem is what? The tangent to any point of a circle is perpendicular to the radius through point of contact. This theorem said that tangent is perpendicular to the radius at a point of contact, which means suppose this is my circle and this circle have a tangent AB, then this tangent AB is perpendicular to the radius at point of contact. Point of contact means, look here, this AB touch this circle at this point, then at this point this radius OP is perpendicular to the tangent AB. Okay, so we have to prove this OP is perpendicular to AB. So first we write what is given. Given is what? AB is a tangent. This is given. Now what we have to prove? To prove is what? Tangent is perpendicular to the radius, which means we have to prove OP is perpendicular to AB. OP is the radius and AB is tangent. So we have to prove OP is perpendicular to AB. Now for this we have to do some construction. For construction, what I do, I take point P dash on AB and point P double dash on tangent AB and join with O. This is my point P dash and I join this point P dash with O center. Then again this is my P double dash and I join this point with center O. Now we have moved towards our proof. Now look here, this is OP. This line intersect this circle at this point. So I name it as OS and this is as OT. Now look here, line OS is smaller than OP dash or line OP dash is greater than OS. So clearly I write here OP dash is greater than OS. Okay. So again I write OP dash is greater than OP. Why OP? Look here, OS is radius, OP is also radius. So OP is equal to OS. So in place of OS I write here OP. and OS is equals to OP. Why? Because they both are radius. Okay, now look. Similarly, line OP double dash. OP double dash is greater than line OT. So again, I write here OP double dash is greater than OT. Now, OT is what? Radius. So in place of OT, I write OP. So again, I will write it here. O double P dash is greater than OP. Why? Because OT and OP both are radius. Now, suppose I take one more point on AB, tangent AB. Suppose I take here a point here P triple dash, and again I join with O. So look here, I take a point P triple dash on this AB at here, and I join this with line O. So I name it this point at M. Now look here, O P triple dash is again greater than OM. So here I write it. OP triple dash is greater than OM. Now OM is what? OM is radius. So in place of OM, again I write OP. So again look here, OP triple dash is greater than OP. Why? Because OM is equals to OP and both are radius. Now look here, from these three, OP dash is greater than OP, O double P dash is again greater than OP, OP triple dash is again greater than OP. So from these three equations, we conclude that OP is the shortest distance. OP is the shortest distance between center and tangent. OP is the shortest distance between center and tangent. Okay. So I suppose this is my equation first. This is second, and this is third. So from 1, 2, and 3, from equation first, second, and third, what we conclude that OP is the shortest distance between tangent AB and center O. Okay. Now we know that shortest distance is the perpendicular distance. So I write it OP is perpendicular to AB. From these three, we conclude that OP is the shortest distance between tangent and center, and we know that shortest distance is the perpendicular distance. So I write it here. We know that shortest distance is the perpendicular distance. Therefore, OP is perpendicular to tangent AB. Now this is proved. Understood? Let's see one more time. This theorem states what? This theorem states tangent is perpendicular to the radius at a point of contact. This tangent AB touches this circle at P. Then at point P, this tangent is perpendicular to the radius. And we have to prove this OP is perpendicular to AB. So for this, I do one construction. I take a point P dash on tangent AB, a point P double dash again on tangent AB, and point P triple dash again on tangent AB. Now look, this is point P dash and this is OS. So from here I conclude that OP dash is greater than OS. So OP dash is greater than OS. Now OS is equal to OP. OS is equal to OP. Why? Because these both are radius. So in place of OS I write it OP. Now similarly OP double dash is again greater than OP, and OP triple dash is again greater than OP. So from this equation 1, 2, and 3, I conclude that OP is the shortest distance. OP is the shortest distance between tangent AB and center O. And we also know that shortest distance is the perpendicular distance. So I write it here, OP is perpendicular to AB. Okay. Now this theorem have one converse, and this converse said what? A line drawn through the end point of a radius and perpendicular to it, then this line is a tangent of a circle. Now look, suppose this is my circle with center O and there is a radius OP, and I draw a line AB, and this line AB is perpendicular to the radius OP. Then by converse of this theorem, I said that this line AB is a tangent for this circle. So this theorem said what? If OP is perpendicular to AB, then AB is a tangent to this circle. Understood? What is converse? If a line drawn perpendicular to the radius of a circle, then this line is a tangent of a circle. Okay. Now let's move towards our next theorem. This theorem said what? The length of two tangents drawn from same external point to the circle are equal. Suppose I draw two tangents from same external point, then by this theorem, I said that these two tangents are equal. Look here, this is my circle with center O, and this is the external point P, and I draw one tangent PQ and one tangent PR from same P point. Then by this theorem, I said that PQ is equals to PR. Understood? So we have to prove this PQ is equals to PR. For this, first I write what is given. So given is what? PQ and PR are tangents for this circle, and what we have to prove? We have to prove that PQ is equals to PR. So PQ is equals to PR. We have to prove this. Now for this we have to do one construction. Construction is what? We have to join O and P. So join OP. This is our construction. Now let's move towards proof. Now look, after joining OP, we have two triangles. First triangle is this PQ and O. Second triangle is PRO. So look here, for these two triangles, OQ, this Q is 90 degree, and OR, again this is 90 degree. Why? Because tangent to radius and tangent both are perpendicular at a point of contact. So this is 90 degree, 90 degree. Okay, now look, hypotenuse. For this triangle, hypotenuse is PQ, and for this triangle, hypotenuse is again PO. So PO and PO are common. Right hypotenuse and one side OQ and OR, both are radius. So right hypotenuse side. By RHS, these two triangles are congruent, and when these two triangles are congruent, then by CPCT, I write PQ is equals to PR. Understood? So first condition, let in triangle PQO and in triangle PRO. So first is angle PQO is equals to angle PRO. Why? Because both are 90 degree. Why 90 degree? Radius and tangent are perpendicular to each other. Second, PO is equals to PO. PO is equals to PO. This is common. Third one is OQ is equals to OR. Why? Because they both are radius of this circle. So from these three, these two triangles are congruent by RHS, right hypotenuse side. So therefore triangle PQO is congruent to triangle PRO. Then by RHS, then by CPCT, we write PQ is equals to PR. By CPCT, PQ is equals to PR. We have to prove this. PQ is equals to PR. Okay, so PQ is equals to PR. Now we have more things by CPCT. If these two triangles are congruent, then by CPCT, PQ is equals to PR, and this angle is also equal to this angle. So I name it angle 1, 2. This angle is also equal to angle this. So I name it 3 and 4. So by CPCT, we get total 3 results. First is PQ is equal to PR. Second result is angle 1 is equal to angle 2. Third result is angle 3 is equal to angle 4. So again I write here by CPCT what we get. First thing PQ equal to PR, that is proved. Now second thing is angle 1 is equal to angle 2, and third thing we get is angle 3 equals to angle 4. 1, 2 and 3 and 4 are equal. Now look, if I write this in statement, so what I write? A line which joining the external point and the center of a circle is bisect the angle between external point and the angle between center of the circle. Okay, so I write it in statement. Point P from two tangents are drawn when join with center, then this line act as a angle bisector of angle between two tangents and angle between radius. Look here, point P from which these two tangents PQ and PR are drawn, and when this point P is joined with center O, then this line PO is act as angle bisector between two angles. First angle is angle between these two tangents QPR, this angle, and second angle is angle between these two radius. Okay, angle QOR. Understood? Let's see one more time. This theorem said that from external point, when two tangents are drawn, then these two tangents are equal. So we have to prove that two tangents from external point are equal. So look, this is my circle with center O, and this is external point P. And from point P, I draw two tangents, which is PQ and PR. Then we have to prove that PQ is equal to PR. So for this, first I do one construction. What is this construction? I join P and O. So after joining PO, I have two triangles. First is PQO and second PRO. So these two triangles are congruent by RHS. Look how this is 90 degree. Why? Because radius and tangent are perpendicular. PO is common and this OQ and OR are radial. So these two triangles are congruent by right hypotenuse side RHS. Then by CPCT I write PQ is equals to PR. Then again I get more results by CPCT. Then these more results are angle 1 is equals to angle 2 and angle 3 is equals to angle 4. And now look, angle 1 and 2 are the angle between these two tangents PQ and QR, and angle 3 and 4 is the angle between two radius OQ and OR. So I write here in statement point P from which these two tangents are drawn, and this point P when joined to the center, then this line PO is act as an angle bisector between the angle between tangents and angle between the two radius. Okay, I hope you all understand these two theorems of this circle. Now let's practice some questions. Our first question is, from an external point P, two tangents PA and PB are drawn to the circle, and we have to prove that OP is a perpendicular bisector of AB. So look here, this is my circle with center O, and from external point P, there are two tangents drawn, which is PA and PB. Then we have to prove that OP is perpendicular bisector of AB. OP, this is a perpendicular bisector of AB. Perpendicular bisector of AB means we have to prove OC is equals to, CA is equals to CB, and this angle is equals to 90 degree. Okay, so we have to prove that CA is equals to CB and this angle ACP is 90 degree, or angle BCP is 90 degree. This is the meaning of perpendicular bisector. So look how we prove. First we write what is given. Given is what? PA and PB are tangents from point P. So PA and PB are tangents from point P. This is given. Now what we have to prove? To prove OP is perpendicular bisector of AB, which means we have to prove that CA is equals to CB, and I name it as angle 1 and this is angle 2. Okay, so we have to prove that angle 1 equals to 90 degree or angle 2 is equals to 90 degree, which means we have to prove that angle 1 is equals to angle 2 is equals to 90 degree. We have to prove this. Okay, so for this we clearly see two triangles, triangle PAC first and second triangle PBC. So we consider these two triangles. So now let's move towards our proof. So first in triangle PCA and in triangle PCB. Now look, in PCA and PCB, this angle is equal to this angle, so I name it as angle 3 and this is as angle 4. So now look how these are equal. In previous theorem we see that line joining center and external point, then this line acts as angle bisector between two tangents and angle between radial. So this angle, this whole bigger angle APB, this whole bigger angle, this line OP acts as angle bisector of angle PAPB. So if this is angle bisector, then angle 3 is equal to angle 4. So first I write Angle 3 is equals to angle 4. How? OP is angle bisector of angle APB. Now second thing is PC is equals to PC. PC is equals to PC. Both are common. Now third thing is PA is equals to PB. Tangent from a standard point are equal. So PA is equals to PB. Tangent from same point P. Okay. So now these two triangles are confronted by side angle side. PC is equal to PC, angle 3, angle 4, and P is equal to PB. So side angle side. So these two triangles are confronted by side angle side. Therefore, triangle PCA is congruent to triangle PCB by side angle side. Now, when these two triangles are congruent, then by CPCT, what I write? CA is equals to CB. Then by CPCT, I write CA is equals to CB. Okay, CA is equal to CB. Now again by CPCT, I write 1 is equals to 2. So angle 1 is equals to angle 2. Again I write. Now look, angle 1 and 2. These 1 and 2 make a linear pair. So from here I write by linear pair, angle 1 plus angle 2 is equals to what? 180 degree. Now these two are equal. So I write it here, angle 1 plus angle 1 is equals to 180 degree. In place of angle 2 I write angle 1. So this is 2 of angle 1 is equals to 180 degree. Now this 180 cancel by 2 in 90 times. So angle 1 is equals to what? 90. Okay, so we have to prove angle 1 is equal to angle 2 is 90 degree and C is equal to CB. C is equal to CB. So this is my equation first, this is my equation second. So now look here, from first and second, I write OP is perpendicular bisector of AB. So from first and second, I write it OP is perpendicular bisector of AB. Okay, this is proved. Let's see one more time. Question said what? There is a circle and two tangents are drawn from same external point P, that is PA and PB. Then we have to prove that this OP is perpendicular bisector of AB. Perpendicular bisector means we have to prove CA is equal to CB and angle 1 is 90 degree or angle 2 is equal to 90 degree. So for this we consider two triangles. First is this one and second is this one, PAC, PBC. Now these two triangles are converted by side and the side. How? PC is equal to PC common, 3 is equal to 4 and PA is equal to PB. So these two triangles are converted by side angle side. P is equal to PB is from theorem second, that is tangent from external point are equal, and 3 is equal to 4 again from theorem second, that is line joining the external point and center is bisector of angle APB or angle between two tangents. So these two triangles are confronted by side angle side. Then by CPCT I write angle 1 is equal to angle 2, 1 is equal to 2 and C is equal to CB. So now look, angle 1 is equal to angle 2 and by linear pair 1 plus 2 is 80. So 180 degree. So in place of angle 2 I write here angle 1. So 2 of angle 1 is equal to 180 degree. Now 180 is cancelled by 2. Then angle 1 is equal to 90 degree. Now from 1 and 2 I write it OP is perpendicular bisector of AB. Okay. Now let's move towards our next question. Next question is what? Prove that the perpendicular at the point of contact to the tangent of a circle is passed through the center. So look here, this is my circle and this is a tangent AB of this circle. So I have to prove that angle PRB, which is 90 degree, or PR is perpendicular to AB, is passed through the center, which means I have to prove line PR is passed through this center. This is we have to prove. So for this, first we do one construction. Construction is draw PR which is perpendicular to the tangent AB. Now let's move towards proof. So look here, this is tangent AB and OR is the radius. So angle ORB is 90 degree. Why? Because radius is perpendicular to the tangent. So I write here angle ORB is equals to 90 degree. Why? Because radius is perpendicular to tangent. Okay. One more thing I write. Angle PRB is 90 degree. Why? Due to construction. I draw PR perpendicular to AB. So I write angle PRB is equals to 90 degree by construction. Now look here. Angle ORB is 90 degree, ORB 90 degree, and PRB is 90 degree. So from these two, I write angle ORB is equals to angle PRB 90 90 RHS are equal, then LHS are also equal. Now angle ORB and PRB are equal when O point lies on PR. Angle PRB is also 90 degree. Okay, and angle ORB is also 90 degree. This is only possible when point O lies on PR. Okay, so right here, this is possible when O lies on line PR. Okay, angle ORB is equal to angle PRB. This is only possible when point O lies on PR. Now from this, I write PR, which is perpendicular to tangent AB, is pass through center. Now this is proved. This one we have to prove. Perpendicular at a point of contact to the tangent of a circle pass through the center. Now perpendicular is what? PR is perpendicular to a tangent AB and is passed through the center. Why? Because O is the center and O lies on PR. So PR is passed through the center AB. Okay, let's see one more time. Question is what? We have to prove that line PR, which is perpendicular to the tangent AB, is passed through the center O. Okay, so first I draw one construction, that is PR is perpendicular to AB. Then by construction I had PRB is 90 degree, and one more thing, angle ORB is also 90 degree. Why? Because radius is perpendicular to the tangent. So now look here, IHS are equal, then LHS is also equal, and now look ORB and PRB. PRB is this angle and ORB is this angle. These two angles are only equal when O lies on PRB. When O lies on PR. So right here, this is possible when O lies on PR. Now when O lies on PR and O lies on PR and O is the center, which means line PR is passed through the center, and which we have to prove that perpendicular at the part which pass through the center. It is PR, which is perpendicular to a tangent, and AB is passed through center. Okay. Now let's move towards our next question. Question is what? There are two concentric circles of radius 5 centimeter and 3 centimeter. Then we have to find the length of the chord of the larger circle which touch the smaller circle. Look, this is my two concentric circle. First one is larger and second one is smaller. So look here, we have to find the length of chord of larger circle. So AB is the chord for larger circle, and this AB is tangent for smaller circle. Why tangent? Because this chord touch the smaller circle. So this chord AB touch the smaller circle at one point. So this AB is tangent for smaller one, and AB is chord for the bigger one. Okay. So we have to find the length of this AB. So look here, this AB touch the smaller circle at point P. So OP is radius, which is 3 centimeter. Now OA is again radius of the larger circle. So OA is 5 centimeter. Now this angle OPA is 90 degree. Why? Radius is perpendicular to the tangent, and for smaller circle this AB is a tangent. So OP is perpendicular to AB. Okay. So first I write what is given. So angle OPA is 90 degree. Why? Because radius is perpendicular to tangents, which means OP is perpendicular to tangent AB. Okay. Now this is 90 degree. So this triangle OPA is a right angle triangle. So therefore triangle OPA is right angle triangle at point P. Now This is right angle triangle, so OA is hypotenuse. Okay. So now by Pythagoras theorem, I write OA square. OA is hypotenuse is equals to OP square plus AP square. So AP is what? So here AP is under root of OA square minus OP square. Now OA is what? OA. This is the radius of larger circle. So OA is 5 and the square of 5 is 25 minus OP. OP is the radius of smaller circle, which is 3 centimeter. So OP is 3. So square of OP is 9. Okay, I write it here. 5 square minus 3 square. Now 25 minus 9 is under root 16. So I get my AP is equals to 4 centimeter. Okay, now AP is 4 centimeter. AP is 4 centimeter. So how I write AB? AP is 4 centimeter. So for AB, if I add AP plus BP, then we get AB, AP plus BP, AP plus BP, then we get AB. Now we have AP, which is 4 centimeter. How I find BP? Now look, AP is equal to BP. Why? Look here. AB is chord of a larger circle and OP is a line which drawn from center to the chord. Then this line is perpendicular bisector of the chord. This theorem we studied in our class 9, that if this is a circle and this is a chord, then a line from center to the chord is perpendicular bisector of this chord, which means angle O, so this is point B, is equals to 90 degree and AP is equals to BP. This is the theorem which we already studied in our class 9, that a line drawn from center to the chord of a circle, then this line is a perpendicular bisector of this chord AB. So same here, AB is the chord of larger circle and OP is a line which drawn from center. Then this OP is 90 degree and OP is bisect the chord AB, which means AP is equal to BP. So in place of BP, I write here AP. Okay. Now look here. AP is 4 and AP is 4. So AB is what? 8 centimeter. Understood? Let's see one more time. Question said that we have two concentric circle. Okay, and AB is the chord of the larger one. Two concentric circles, smaller and larger one, and AB is the chord of the larger circle. Then we have to find the length of AB and the radius of these two circles are given. 3 is the radius of smaller circle and 5 centimeter is the radius of larger circle. So look here, AB is the chord for larger circle and this AB touches the smaller circle, then this AB is tangent for a smaller circle. So now radius and tangent are perpendicular to each other. So I write here OPA is 90 degree, radius is perpendicular to the tangent. So now if this angle is 90 degree, then this triangle OPA is a right angle triangle at P. I write it here, OPA is right angle triangle at P. Now I applied Pythagoras theorem in this. Then by Pythagoras theorem, hypotenuse equals to perpendicular plus base square. So OA square is equal to OP square plus AP square. So now AP is what? Under root OA square minus OP square. Now after calculation, I get AP is 4 centimeter. Now AP is 4 centimeter. This part is 4 centimeter, but we have to find the AB. So for AB, I write AP plus BP. If I add AP and BP, then I get AB. Now I have AP, but I don't have BP. So how I find BP? So recall your first theorem of class 9, which said that line drawn from center to the chord is perpendicular bisector to the chord. If this is a chord and a line drawn from center, then this line is perpendicular bisector of the chord. Perpendicular bisector means make 90 degree and bisect the line AB, which means this is equal to this. So here OP is the line drawn from center for the larger circle, then this OP bisect the line AB, which means AP is equal to BP. So here I write in place of BP I get AP. Why? Because AP is equal to BP. So now AP is 4 plus 4 is 8 centimeter. So AB is 8 centimeter. Okay. Now let's move towards our next question. Question is what? In figure, this is our figure. XY and XY are two parallel tangent to the circle. This circle, this XY tangent and X dash Y dash tangent. These two are parallel tangents and this circle is center O, and another tangent AB with point of contact C. Now another tangent this AB which touch this circle at point C and intersect xy at A and x dash y dash at B. Then we have to prove that angle AOB is 90 degree. Angle AOB. Okay, we have to prove that this angle AOB is 90 degree. Okay, so first I write what is given. Given is xy and x dash y dash and AB are the tangents. Now what we have to prove? To prove angle AOB is 90 degree. Angle AOB is equals to 90 degree. Now for this we need one construction. Construction is what? We have to join O and C. So we have to join OC. Now look, we have one triangle, two triangle, three triangle, four triangle. Now these two triangles are congruent and these two triangles are congruent. Look how. In these two triangles, OP and OC is 90 degree. OP radius XY is tangent. So radius is perpendicular to the tangents. Then this angle is 90 degree. And now in this case, AB is tangent. OC is radius. So this angle is 90 degree. Okay. Now hypotenuse RHS. AO. AO is both common for these two triangles. So write hypotenuse. Now one side. OP is radius, OC radius. So write hypotenuse side. So by RHS these two triangles are congruent, and similarly by RHS these two triangles are congruent. Okay. So let's do it here. Now proof. First we consider in triangle OPA, OPA, and in triangle OCA. Now angle OPA and angle OCA is 90 degree. So angle OPA is equals to angle OCA, both 90. Second thing is OA is equals to OA, which is common. So OA is equals to OA, common. And third is OP is equals to OC, which is radius. So here OP is equals to OC, that is radius. Now from these two triangles are congruent by RHS. So therefore triangle OPA is congruent to triangle OCA by RHS. Then by CPCT, we write angle POA is equal to angle OCA. This angle is equal to this angle by CPCT. So angle POA by CPCT, right here, angle POA is equals to angle COA. Okay. Now similarly these two triangles are also congruent. So I write it here. Similarly triangle QOB and triangle BOC are congruent. So similarly triangle QOB is congruent to triangle BOC by RHS. Then again by CPCT we write angle QOB is equals to angle BOC. QOB, this angle is equal to this angle. Okay, and emitter 1, 2, and this is 3 and 4. So angle QOB 3 and angle BOC 4 are equal. So angle BOC. Okay. Now look here, angle 1, 2, 3 and 4. These angles are on linear pair. So I write it here. Bilinear pair, no, right here. Then by linear pair, angle POA plus angle COA. Okay, angle POA plus angle COA. I make it properly. This angle is equal to this angle, and this angle is equal to this angle by CPCT, and this angle is equal to this angle by CPCT. Okay, so now angle POA and COA. plus angle COA. Now plus angle QOB plus angle BOC is equals to 180 degree. Now in place of POA, I write COA. POA plus COA. Look here, POA is equal to COA. So in place of POA, I write angle COA plus angle COA plus now QOB is equal to BOC. Okay, QOB, this angle equal to this angle. So in place of QOB, again I write BOC. So angle BOC plus angle BOC is equal to 180 degree. Now I write it here upside. Okay, so from here I write it. Now look, angle COA plus angle COA is equals to 2 of angle COA plus BOC plus BOC is what? 2 of angle BOC is equals to 180 degree. Now we take 2 as common, then 2 of angle COA plus angle BOC is equals to 180 degree. Now this 180 degree cancel by 2 at 90 times. So from here angle COA plus angle BOC is equals to 90 degree. Now look angle COA. Angle COA, this angle. Now angle COA, this one, COA and BOC, this one angle, BOC and COA. If we add these two angles, then we get angle AOB. So here angle AOB is equals to 90 degree. This is proved. We have to prove this. Angle AOB is equals to 90 degree. So angle AOB is 90 degree. Let's see one more time. Question said that there is a circle with center O and XY and X dash y dash are two parallel tangent to this circle and one another tangent AB which touch this circle point C, and this tangent intersect xy at point A and x dash y dash at point B. Then we have to prove that angle AOB is equal to 90 degree. So for this I do one construction. I join O and C. Okay, so join OC and we have to prove angle AOB is 90 degree. So for this, look here, first I consider these two triangles, and these two triangles are congruent by RHS. How? 90 degree, 90 degree. Radius is perpendicular to a tangent, so OP is radius, OC is radius, which is perpendicular. So 90 degree. Now OA is equal because common. Now OP is equal to OC. Why? Because radius. So these two triangles are congruent by right hypotenuse side, RHS. Then by CPCT, I write angle POA. This angle POA and this angle COA are equal by CPCT. Then similarly these two triangles are also congruent, and by CPCT angle QOB, this angle, and angle BOC, this angle, these two are equal. So I write it here. Now look here, this is PQ is a straight line, and this angle, this angle, this angle, this angle, all four angles make a linear pair. So I write here by linear pair POA this angle, COA this angle, QOB this angle, and BOC this angle is equals to 180 degree. So now in place of POA, I write COA. Why? Because this one are equal. POA and COA are equal, and QOB and BOC angle are equal. So in place of QOB, I write BOC. Now COA is 2 of COA. BOC is 2 of angle BOC is equals to 180 degree. I take 2 as common. Then angle COA plus angle BOC is equals to 180 degree, and this 180 degree is cancelled by 2, 90 degree. Then angle COA plus angle BOC is 90 degree. Angle COA, this angle COA, this angle plus BOC, this angle, these two, the sum of these two angle is 90 degree. Okay, now when you add these two angles, then I get bigger one, that is angle AOB. So that angle AOB is equals to 90 degree. Proved. We have to prove angle AOB is 90 degree. Okay, now let's move towards next question. Question is what? Prove that the angle between two tangents drawn from same external point to a circle is supplementary to the angle separated by the line segment joining the points of contact of the center. Look, we have one circle with center O and two tangents PA and PB drawn for this circle from same external point P. Then we have to prove that angle between two tangents and this angle, between this angle plus this angle, we have to prove that this angle APB and angle AOP is supplementary. Supplementary means sum of these two angles is 180 degree. So we have to prove that angle APB plus angle AOB is equals to 180 degree. Okay, so let's start the proof. Now look, we have two triangles. First triangle is this one PAO and second triangle is PBO. So by angle sum property, what I write? First in triangle this PAO. Okay, in triangle PAO by ASM, which is angle sum property, I write angle PAO plus angle APO plus angle AOP is equals to 180 degree. Sum of all angles of a triangle are 180 degree. So now look, PAO, this one is 90 degree. Why? Radius OA and tangent PA are perpendicular to each other. So angle POA is 90 degree. Okay. Now this angle goes to this side. So angle APO plus angle AOP is equals to 180 degree minus, now angle POAO is 90 degree. So I have angle APO plus angle AOP. Angle AOP equals to 90 degree. This is my equation first. Now similarly in this triangle PBO. Similarly in this triangle, similarly by angle sum property in triangle this PBO, I write angle BPO plus this angle BOP. Angle BOP equals to 90 degree. Look how I apply angle sum property in this triangle, then angle BPO plus angle PBO plus angle BOP. Sum of all angle is 90 degree. So now look, this angle BPO, this one, and BOP, this one is equals to what? 180 minus this angle, which is 90 degree. So 180 minus 90 is 90 degree. So I write it here, angle BPO plus angle BOP is 90 degree. This is my equation second. Now I add this equation first and second. So now add equation first and equation second. So equation 1 is APO, angle APO plus angle AOP plus angle AOP. Okay, now LHS of second one, angle BPO plus angle BPO plus angle BOP is equals to what? 90 plus 90. 90 plus 90. Now look, angle APO is where? Angle APO. This angle and angle BPO, this angle. APO and BPO. If I add angle APO and angle BPO, then we get the bigger angle, which is angle APB. So angle APO plus angle BPO is equals to angle APB. Now plus angle AOP, this angle, and angle BOP, this angle. If we add these two angles, AOP and BOP, then we get the bigger angle AOB. So angle AOB is equals to what? 90 plus 90 is 180 degree. We have to prove this. Angle APB plus AOB is 180 degree. Angle between tangent and angle between radius are supplementary. Okay, let's see one more time. Question said that there is a circle with center O and two tangents drawn for this circle from same external point. Okay, tangent PA and PB drawn from same external point P. Then we have to prove that angle between two tangents drawn from same external point to a circle is supplementary to the angle separated by the line segment joining the 2 points of contact, which means we have to prove angle between these two tangents and angle between these two radius is supplementary, which is angle APB. Angle APB plus angle AOB is equals to 180 degree. Supplementary means sum of two angles are 180 degree. So for this, first I consider this triangle POA, okay, triangle PAO, and I apply angle sum property in this triangle. Angle sum property is what? Sum of all angles is equals to 90 degree. So sum of all angle is 180 degree, not 90 degree. Now angle APO plus angle AOP is equals to 180. Now this angle PAO is 90 degree. Why? Because radius and tangents are perpendicular to each other. So 180 minus 90, which is 90 degrees. So angle APO plus angle AOP is 90 degree. And similarly, by angle sum property in this triangle, I write angle BPO plus angle BOP is 90 degree. Now this is my equation first, this is equation second. Now I add these two equations. So by adding these two, APO plus AOP, this, and LHS of this BPO and BOP is equal to 90 plus 90. Now angle APO, this angle, and angle BPO, this angle. If I add these two angles, then I get a bigger one, that is AOB. APB, I write it here, APB. Now angle AOP, this one, and angle BOP, this one. If I add these two angles, then I get bigger one, which is AOB. So AOB is equal to 180 degree. Now this angle is the angle between tangent, and this angle is the angle between radius. And the sum of these two is 180, which means these two angles are supplementary. Okay. Now let's move towards our next question. Question is what? A quadrilateral ABCD is drawn to circumscribe a circle. Then we have to prove AB plus CD is equal to AD plus BC. Look, there is a quadrilateral ABCD, and this quadrilateral circumscribe a circle. Circumscribe a circle means this circle lies under this quadrilateral ABCD. Okay. So we have to prove that AB plus CD is equals to AD plus DC. Understood? Let's see it how we prove. First I write what we have to prove. So we have to prove that AB plus CD is equals to AD plus BC. So now let's move towards proof. Now see, this is a point P, line AB touch this circle at point P, then AB is a tangent, same line BC touch this circle at point Q, so line BC is also a tangent, and DC again touch the circle at point R, so DC is again tangent, and DA again it touch the circle at point S, so AD is also a tangent. So now look, AP and AS, tangent AP and AS are equal. Why? Because these two tangents are drawn from same external point A. That's why AP and AS are equal. So first I write here AP is equal to ASY tangent from same point. Now similarly BP is also equals to BQ. BP is equals to BQ. BP is equals to BQ. Similarly CQ is equals to CR. So CQ is equals to CR, tangent from same point, tangent from same point. Okay. Now DR is equal to DS, tangent from same point D. So here DR is equals to DS, again tangent from same point. Now we have to prove AB plus CD. So AB plus CD. So now for AB plus CD, what we write? AB plus CD is equals to what? AB and CD. This is AB and this one is CD. So look here, AB. If I write AB as AP plus PB, AP plus PB is equals to AB. So for AB, I write here AP plus PB. Then plus, now for CD. CD is this. So for CD, I write CR plus DR. So CR plus DR. Okay. Now write AD plus BC. Okay. So AB plus CD is this one, and AD plus BC is what? AD plus BC. AD is where? AD is this one. So for AD, I write AS plus DS. So for AD, I write AS plus DS. Now plus BC. BC is here. So for BC, I write BQ plus CQ. So BQ plus CQ. Now look, AP and AS. Here AP and AS are equal. PB and DS. PB, where is PB? Is equal to BQ. This is PB is equal to BQ here. So in this, in place of AS, I write AP. AP in place of DS. DS. In place of DS, I write DR. So in place of DS, I write DR. Now plus BQ. In place of BQ, what I write? BP plus CQ is where? In place of CQ, I write CR. So CR. Now compare this one. AP, DR, BP, CR. AP is here, DR is here, BP is here and CR is here. Okay. So this is my equation first and this is my equation second. So from first and second, RHS is equal. Therefore, LHS is also equal. So I write it here from equation first and equation second. AB plus CD is equals to AD plus BC. AD plus BC. Now this one is proved. Okay, let's see one more time. Question is what? There is a quadrilateral ABCD and this quadrilateral circumscribe a circle in this, and this circle touch the sides of the quadrilateral at point P, Q, R and S. Then we have to prove that AB plus CD is equals to AD plus BC. So for this, first see, AB is a tangent. Why? Because AB touch the circle at point P, one point. BC is also tangent for this circle because BC touch this circle at point Q. DC is also tangent because this touch at R, and similarly AD is also tangent for this circle. Why? Because this AD touch this circle at point S. Now look, AP is equal to AS. AP is equal to AS. Why? Because this both AP and AS drawn from same external point A, that's why AP is equal to AS. Similarly, BP is equal to BQ, and similarly CQ is equal to CR, and similarly DS is equal to DR. That's why I write. Now AB plus CD. AB plus CD is what? AB is, if I add AP and PB, then I get AB. So in AB is AB plus PB, and now CD. If I add CR and DR, then I get CD. So CD is what? CR and DR. Now AD plus BC. What I get? AD plus BC. So AD is what? AD. AS plus DS is equal to AD. So in place of AD, I add AS plus DS. Now BC. BC. If I add BQ and CQ, then I get BC. So I write here BQ plus CQ. Now look, AS is equal to AP. So I add in place of AS AP. DS is equal to DR. So in place of DS, I write DR. Now BQ is equal to BP. So in place of BQ, I write BP. And now CQ. CQ is where? This one. So CQ is equal to CR. So in place of CQ, I write CR. Now compare this first equation and second equation. RHS of both first and second are equal. AP plus PB, AP, PB, CR and DR. So from first and second, RHS are equal. Therefore, AB plus CD equals to AD plus BC. RHS are also equal. Understood? Now let's move towards next question. Question is what? Two tangents TP and TQ are drawn to a circle with center O from external point T. Then we have to prove that angle PTQ is equal to 2 of angle OPQ. Look, this is my circle with center O and two tangents TP and TQ is drawn from same external point T. Okay. Then we have to prove that angle PTQ, this angle is equal to two types of angle OPQ. This one, this angle is equal to two times of this angle. We have to prove that. Okay. So let's see it. First, I write what we have to prove. To prove angle PTQ is equals to 2 of angle OPQ. Okay. Now we consider this triangle PTQ. We consider this triangle PTQ first. So proof. Now in triangle PTQ, we use angle sum property. In triangle PTQ, by angle sum property ASM, that is angle sum property, this angle plus this angle plus this angle are equals to 180 degree. So angle PTQ, this angle PTQ plus, I name it, this angle is 1 and this is also 1. Why? Because TP and TQ are equal, then this angle are also equal, so I name it 1 and 1. So angle PTQ plus angle 1 plus angle 1 is equals to 180 degree by angle sum property. Now, so angle PTQ plus 1 is 2 of angle 1 is equals to 180 degree. So now look how we find angle 1. Look here. This angle is, this one is angle first, and now look, angle OPQ, this angle OPQ, this angle is 90 degree. Why 90 degree? OP is radius and P is a tangent. So radius is perpendicular to the tangents. That's why angle OPT. This angle is 90 degree. So now this one is 90 degree. So how I find angle 1? If I subtract this angle OPQ from OPT, angle OPT minus angle OPQ, then we get angle 1. Look here. OPT, this angle. OPT is this one, bigger one. OPT is this angle. OPT, this angle. Okay, this is OPT, and from this angle I subtract angle OPQ, this angle. From this bigger angle I subtract this smaller one. Then I get this angle, which is angle 1. Understood? So I write here OPT. This one is bigger angle, and this one OPQ. OPQ smaller angle. When I subtract this smaller from this bigger one, then I get angle 1. So I write it here angle 1. So angle 1 is first to what? OPT minus OPQ. So in place of angle 1, I write this angle PTQ plus 2 of angle 1. Now angle 1 is OPT minus OPQ. Now OPT, angle OPT. This is angle OPT and this is 90 degree. So 90 minus angle OPQ is equals to angle 1. So angle 1 is 90 minus angle OPQ. So 90 minus angle OPQ is equals to 180 degree. Now angle PTQ plus 90 into 2 is 180 minus this is 2 and this is OPQ. So this will become 2 of angle OPQ is equals to 180 degree. Now 180 is cancel out. Now this is minus of 2 of angle OPQ. Now this goes this side, which becomes 2 of angle OPQ plus, so angle PTQ is equals to plus 2 of angle OPQ. Now we have to prove this. Angle PTQ is equals to 2 of angle OPQ. So angle PTQ is equals to angle 2 of angle OPQ proved. Understood? Let's see one more time. Question said what? There is a circle and two tangents are drawn for this circle from same external point T. Then we have to prove that angle PTQ, this angle PTQ is twice of this angle OPQ. Okay. So for this I consider triangle PTQ. So in triangle PTQ I use angle sum property of this triangle, which is sum of all angles is equal to 180 degree. So angle PTQ plus, I name this angle as 1 and this angle is also 1. Why? Because these two are equal. These two sides are equal, then these two angles are also equal. So angle PTQ plus angle 1 is 180 degree. So from here angle PTQ plus 2 of angle 1 is 180 degree. Now look how I find angle 1. So for angle 1, this one is bigger angle OPT, I subtract this angle, smaller angle OPQ. I subtract this angle OPQ from this bigger angle OTQ. Then I get this angle 1, which is angle QPT. So for angle 1, I subtract OPQ from OPT, and OPT is what? OPT. This angle is 90 degree by 90 because radius. This one is OP is radius and P is tangent. So radius is perpendicular to the tangent. Therefore, this one is 90 degree minus OPQ is equal to angle 1. So in place of angle 1, I write 90 minus OPQ. Now I multiply with the 90 into 2 is 180, and this will become 2 of angle OPQ. Now 180 is cancel out. So what we left, angle PTQ is equals to this minus goes this side and become plus. So angle PTQ is equals to 2 of angle OPQ. Understood? Now let's move towards our next question. The question is what? In figure, PQ is a chord of length 8 cm of a circle. There is a circle with center O, and in which PQ is the chord for this circle with length is 8 cm and radius of the circle is given 5 cm. Okay, so radius is OP, which is given 5 cm, and this PQ is given 8 cm. And TP and TQ are two tangents drawn from same external point T. Then we have to find the length of TP. We have to find the length of TP, this one. Okay. So for this, first I write what is given. So OP is given, which is 5 cm, and length of chord, which means PQ is given, that is 8 cm. Now look, TO is perpendicular bisector of PQ. How? Recall first question, that is line joining external point and center of a circle is perpendicular bisector of the line joining the point of contact of two tangents. Recall the first question. So I write it here, TO is perpendicular bisector of PQ. Now TO is perpendicular bisector of PQ. So from this I write what? If TO is perpendicular bisector, then I name this point R. Okay, so then PR is equals to QR. When TO is perpendicular bisector to PQ, then PR is equals to QR, and angle PRO is equals to what? 90 degree. Okay, angle PRO is 90 degree. This angle, and angle PRT is also 90 degree. Okay, what I do first, I write what is given. Radius is given 5 centimeter. Length of chord PQ is given 8 centimeter. Now TO is perpendicular bisector to PQ. So from this I write PR is equals to QR, PR is equals to QR, and angle PRO is 90 degree. Now we consider this triangle, triangle PRO. This is a right angle triangle. Why? Because this angle is PRO is 90 degree. So now in right angle triangle, PRO, we use Pythagoras theorem. In right angle PRO, this is 5 centimeter hypotenuse, and PR is what? PR is equals to QR. PR is equals to QR. Okay, and PQ. Look here. PQ is 8 centimeter. Now we write PQ as PR plus QR is equals to 8 centimeter. Now these two are equal. So from here I write 2 of PR is equals to 8. So PR is what? 4 centimeter. So look here, PR is 4 centimeter in right angle triangle. Now PR is 4 centimeter. So we use Pythagoras theorem. By Pythagoras theorem, Pythagoras theorem is what? PO square hypotenuse square is equal to perpendicular square plus base square. So perpendicular is PR. So here PR square plus OR square. Okay. So now we find OR from here. So OR is what? Here OR is under root of PO minus PR square. So PO is what? PO. This one is radius, just 5. So square of 5 is 25. Now PR is what? 4. So square of 4 is 16. So from here this is equals to what? 9. So OR is 3 centimeter now. Now OR is 3 centimeter. This one is 3 centimeter. Okay. But we have to find the length of TP. TP. We have to find TP, not OR. So for TP, we consider this triangle. PTO. Okay. PTO. This triangle. Okay. So now in triangle PTO, look here, in triangle PTO we have the length of OP, which is 5 centimeter. We have to find the length of TP. We have OP, we have to find the length of TP. Now we use trigo. Okay, now we use trigo. Look here, this angle I suppose theta. Okay, this angle POT, this is theta. Then I use tan theta. Tan theta is what? Perpendicular upon base. So we consider this angle. So for this angle perpendicular is what? For this angle perpendicular is this. Why I use trigo? Look, this triangle is right angle triangle. Again, why? Because OP is radius and TP is tangent. Then this angle is 90 degree. So this is a right angle triangle. OPT is right angle triangle. So for this one is TO is hypotenuse. Now look, we assume tan theta. Tan theta is P by B. So for this perpendicular is this one TP. So TP upon base is what? OP. OP. Okay. Now what is tan theta? How we find tan theta? Look here. This theta comes in PTQ triangle and again PRO. This is our PRO. In this triangle again theta comes Okay, so from this right angle triangle PRO, we find tan theta. So look here, for in this triangle we find tan theta. So for triangle PRO, tan theta is what? Perpendicular upon base. This is 90 degrees, so this one is hypotenuse. So P is what? PR is P and this is base. RO is base. So P is PR. So now look, PR is what? PR is 4 centimeter. So tan theta is PR upon RO, and PR is 4 and RO we find 3. So tan theta is 4 upon 3. So in place of tan theta I write it here 4 upon 3 is equal to, now we have to find TP and OP. OP is what? 5. So 5. Now calculate this one. So from here TP is what? TP is 5 into 4, which is 20 upon 3. Now this is our TP, which is 20 upon 3 centimeter. Okay, let's see one more time. Question said what? There is a circle with center O and two tangents TP and TQ drawn from same external point P. Okay, and the radius of the circle is given 5 centimeter, and this circle have one chord which is PQ, and the length of PQ is also given, which is 8 centimeter. Then we have to find the length of TP. Okay, so for this, first I write what is given. So OP is radius 5 centimeter given, PQ is chord which is given 8 centimeter. Now look, first question, by first question I write TO is perpendicular bisector to PQ. TO is perpendicular bisector to PQ. So TO is perpendicular bisector to PQ. Then from this I get PI is equals to QR. When TO is perpendicular bisector, then PR is equals to QR, and angle PRO is equals to 90 degree. Okay. So now look. Then after I consider triangle PRO. PRO is 90 degree. Then this is right angle triangle PRO. Now in this triangle I use Pythagoras theorem to find the length of RO. So after Pythagoras theorem I find RO or OR is 3 centimeter. Now I take trigo ratio, that is tan theta. Now in this triangle I use tan theta. So this one is my theta angle. So tan theta is P by B. So for this triangle, hypotenuse is this one PO, and this is my theta. Then perpendicular is this PR, and base is RO. So P by B is PR by RO. PR is 4 centimeter and RO is 3 centimeter. I find it. Now I use this triangle, bigger one, PPO. This triangle is again right angle triangle. Why? Because OP is radius and TP is tangents. Now radius is perpendicular to the tangents. That's why this is a right angle triangle. And for this triangle, hypotenuse is TQ, TO. Okay. Now in this triangle, I use again tan theta to find in TP. So tan theta is what? This is my theta angle. So theta is, tan theta is P by B. So for this, perpendicular is TP and base is OP. So tan theta is TP upon OP. Now I find the value of tan theta, that is 4 upon 3. So I write tan theta is 4 upon 3 is equals to TP, and OP is 5. So from here TP is 20 upon 3. Okay. Now the chapter circle is over here. If you found this video helpful, then please like, share and subscribe to the Brilliant Academy. Okay. Thank you.